Oh, I didn't see you guys there. Welcome. I was enjoying some water. Hydration is always a very, very important thing. And I hope you guys stay hydrated. And that brings us to today's theme, hydroelectricity. So join me as we go on a little ride through hydroelectricity. All right, guys, as you can see, we are going to discuss in this video, hydroelectric power. So let's dive right in. Hope you saw that one. Get ready, because hopefully this video is full of corny jokes. So hydroelectricity, that is electricity due to water. Before we even begin, you need to understand how you generate electricity. What's that? What's that? You already know how? Well, tell me. Yeah, that's connected to. Yeah, and that power's made up of two things. Yeah, okay. I guess you do know this, right? Turbine's connected to a generator. Generator is made up of a coil of wire and a magnet, and that gives us electricity. Perfect. You guys are pros at this. So let's see exactly then how water can make electricity. So 10% of the US power is from hydropower, and that roughly accounts for 19% of the world's power. So when we think of energy, in the simplest terms, we're thinking of potential energy and kinetic energy. And I know you understand what potential and kinetic energy are. Potential energy is stored energy. It's energy usually of height. It's not always the case. That's gravitational potential energy. And if you were in my physics class, you would remember that, GPE, right? Potential energy can also be due to other things. It could be chemical potential energy. It could be energy in the form of bonds. It could be energy that's stored in a motor due to friction. So it is stored energy. Now your kinetic energy, it's pretty straightforward. That's energy of motion. So we are essentially taking the water behind a dam and then we're releasing it. And as it releases, it's moving. The stored water, which held potential energy, is now moving, transferring to kinetic energy. As that water moves, it travels. Take a look at the diagram here. It travels and follow my, spotlight. It travels down through a penstock. That then travels through a turbine. Essentially, you have the running water traveling through this small area. And think of it as like this little water pump, right? Only in an opposite direction. The water's pushing and it's pushing the pump and it's making it turn, turn, turn. Well, guess what, guys? That pump is connected to, well, that is your turbine. That's connected to a generator. Generator is made up of a coil of wire and a magnet, and that gives us electricity. After the water has turned the turbine, it then just continues on its way down the river. All right. Moving on, we see producing electricity from the water cycle. Water flowing in rivers and streams can be trapped in reservoirs, behind dams, and released as needed to spin turbines and produce electricity. There's little room for expansion in the US. Here's the downfall. 98% of the dams and rivers have been used up. Okay, think about it. There's only so many dams and rivers that are available. If we have put there's only so many rivers that are available. If we have dammed them up already and we've created hydroelectric dams, you can't make a river. I mean, you could, but you can't make a river large enough and divert enough water because you'd be taking it away from somewhere else. So this is kind of like a fixed resource. Moving on, hydroelectric disadvantages. As always, you need to remember, there are always advantages, but there's also those disadvantages. Changes in natural river flow, and a lot of these disadvantages maybe have more of an effect on the environment than does, say, wind power or geothermal or biomass. Okay, because these are changing the flow and current of rivers, of our river system, the migratory patterns of organisms, mainly fish. Changes in natural river flow destroys ecosystems both above and below the dam, affects fish migration, high evaporation rates in dry areas. So let's dig a little bit deeper on some of these. Destroys ecosystems above and below the dam. Above, think about it. You are now flooding an area to create a reservoir that never had this degree of water before. Below the dam, you have taken this current, this stream of water, and you've now essentially dried it up because now you're holding that water back. So you're controlling the amount of current, the amount of water that's coming out and traveling downriver. Fish migrations. Fish often travel upstream in order to reproduce, to breed. If you put a dam there, it's like a big giant wall saying, I'm a fish, I'm a fish, I'm a fish, boom. Can't go no more. So what do? There's ways around that. They create fish ladders. And high evaporation rates in dry areas, when you start pooling a reservoir above the dam, right, on the reservoir side, now you have this large surface area, okay, with all this water in it. That's going to increase the evaporation rate because now you have this giant surface of water, more area for water to evaporate. Advantages and disadvantages. Again, advantages. It's great. It's highly efficient. Low electricity cost. Long lifespan. May provide flood control below the dam. It's important. Reservoir is useful for fishing and recreation above the dam, right? We have just created essentially a lake. Disadvantages. High construction costs, as well as very dangerous. Floods natural areas behind the dam or above the dam. Danger of collapse. What happens if this thing lets go? Okay, I remind you of the video Evan Almighty, where the dam let go in the very end. That thing just kind of wrecked. I know it was a movie, but just imagine if a dam were to let go, those millions and millions of gallons of water just released. Think about the West Thompson Dam. Decreased fish harvest below the dam. Decreased flow of natural fertilizer or silt to land below the dam. Okay, all very important things to think about. Also very important if you have to argue, say there's a question about dams on the FRQ portion of your AP exam, you need to be able to argue both the advantages and the disadvantages. Producing electricity from the water cycle, ocean tides and waves, and temperature differences between surface and bottom waters in tropical waters are not expected to provide much of the world's electrical needs. This is more speaking along the lines of tidal energy. Remember, we have such a large mass of water, the ocean, moving in and out daily, roughly every 6 hours, your tides, your high tide and your low tide. Think about that massive amount of water moving in for 6 hours. If you were to put a tidal generator along a beach, maybe even the Bay of Fundy, where the tide swings are roughly 40 feet, imagine that amount of water coming in, spinning a turbine, and then receding, spinning that turbine. You could generate a good amount of energy that way. But only 2/3 of large tidal energy dams are currently operating, one in Lorance, France, and Nova Scotia's Bay of Fundy, where the tide is much as 63 feet. Okay, so even though we can generate electricity, it is not a very well-used technology. And again, think about the ocean creatures, the marine organisms that could be harmed by this. I want you to understand renewable energy is a great thing, but with everything else, there are disadvantages. Just because it's renewable, just because it is, maybe the answer to our fossil fuels, there are still disadvantages. Excuse me, guys. I need to blow my nose. I'll be serious now. That was a little joke. Hopefully it made you laugh. Off camera here. Hold on. Almost there. And we're back and we're feeling good. So not only do we have energy due to flowing river waters as well as tidal waters. Now, I also want you to think, I don't know if you picked it up, but in the solar energy video, we saw both wind turbines that were on the horizontal axis this way. So they spun like a fan, think about a fan. And we saw them both and also as well as on the vertical axis. And those spin in this direction. They look almost like a weird, I really don't have anything, but they look almost like this weird type of, let's see if I can draw it. They almost look like a drum, and they have these weird blades that as the wind blows over them, they're spinning in this direction. They're going around in a circle. Okay, that is a vertical axis wind turbine, and your regular fans, those are your horizontal axis wind turbines. Well, the tidal rivers, or excuse me, the ocean tidal electricity would be more along the lines of a horizontal axis turbine. Let's keep moving on. We are almost there, guys. Here again, we see the tidal areas. Tidal barrage, collects water behind the dam as tide comes in. It releases it as the tide goes out through a turbine. That turbine spins a generator, and that creates our electricity. All right, same idea, guys. We're just moving this giant mass of water through turbines. And our last one, our last slide of the day. Here's a tidal generator. This one is slightly different than a vertical axis wind generator. This is a horizontal axis tidal generator. My main concern with this one is, and I hope you're thinking the same thing, what happens when the marine organisms swim around those spinning blades? Could do quite some damage, especially, boats. They can create quite a bit of turbulence up above. The idea is wonderful. The idea is great. I'm sure it can be tweaked in a number of areas. But again, you need to understand the positives and negatives. So I hope you've enjoyed tidal and hydroelectric energy. That is it for me with this video, energy due to water. And I will see you guys in the next video. Bye, PHS.